Okay, so this last arithmetic sequence example kind of covers every type of problem I could ask you about these up to this point. Okay, so we're given a sequence 52, 39, 26, dot, 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 and then notice that the sequence ends. Okay, so this is a finite sequence. Okay, so there's a beginning 3, there's a dot, dot, dot in the middle. We don't know how many numbers are in there, but it seems like a lot. And then there's 3 at the end. Okay. And then again, we're going to write a formula. We're going to find the 12th term. We're going to figure out which term is negative 182. So that negative 182 is somewhere in that dot, dot, dot. And then we're going to find out how many terms are in this sequence. Okay. Now remember to write the formula. The formula for an arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times d. Okay. And the important things that we need to be able to write this formula is we need the first term and we need the common difference. Okay, and both of those are going to be found just looking at the sequence. Okay, looking at the sequence, we know the first term. The first term is the first one listed. It's 52. You can plug in 52 for A1. And then you have to figure out what the common difference is, and doing that is just finding the pattern. How do you go from 52 to 39? How do you go from 39 to 26? Okay, and then you could do the same on the back end. Well, 52 to 39 and 39 to 26 is subtracting 13. So our common difference is negative 13. So we can put that in the back spot where D goes. Now the rest of this is just your dependent variable and your independent variable. So those are going to stay in the equation. Now to finish writing the formula, all we're going to do is distribute and then combine like terms. I'm going to move this stuff down so I have some room to work. We'll get to that in a second. Alright, so distribute the 13, the negative 13. You're going to kind of backwards distribute because it's at the end. Leaves us with a sub n equals 52 minus 13n. Negative 13 times n, and then plus 13, negative 13 times negative 1 gives you positive. All right, and then from here, all it is combining like terms. We have a 52, we have a plus 13. So our final equation to find the nth term, any term, a sub n, is going to equal negative 13n plus 65. And that is our explicit formula, and this formula is going to help us find any term in the sequence. Okay. Which brings us to the second problem. Find the 12th term. Okay. Now again, 12 is low enough where you might want to just do minus 13 12 times. Okay. But we're going to want to use the formula as much as we can. So if you want to find the 12th term, you're saying your n value, your term number, is 12. So we're going to be finding a sub 12. And we're just going to plug that into the formula where n is 12. So a sub 12 is negative 13 times 12 plus 65. And that's just evaluating. Negative 13 times 12 plus 65 is negative 91. So the 12th term in the sequence, if you would have kept doing minus 13, minus 13, minus 13, the 12th spot in that ordered set is negative 91. Okay. The next problem, which term is negative 182? Okay. So remember, there's a lot of terms in that dot, dot, dot area where the pattern continues, but not everything's listed. So finding out which term is 182 is the same thing as giving us the output, and we need to find the input. We need to find n. So in our equation, which again is listed up here in light blue, negative 13n plus 65, we're going to be solving for n, which means we know the output. We know the answer. The term value is negative 182. We don't know what term number it is, though. So we know the value, which is the output, but we don't know the number, which is the input. So we're just going to solve for n in this one. This is a two-step equation. We've done plenty of these. Subtract 65 on both sides. Okay, because you're switching sides. And then divide by negative 13. So when you do negative 247 divided by negative 13, you get an n value of 19. Okay. Now what does that mean? It means that the 19th term is 182, negative 182. So a sub 19 is negative 182. Because again, we knew the value, but we didn't know where in the sequence it fell. And it's the 19th term. All right, and the last one's a little different. How many terms are in the sequence? Before this, all of our examples were infinite sequences. So they never ended. So there wasn't, it just kept going on forever and ever. This one does end. We want to know how many terms are in the sequence. So to do that, we're going to need to know some more information from the original sequence. The only thing we need to know is we need to know what the last term is. The last term is negative 286. We know the value, but we don't know which number it is in the sequence. Okay. So it's just like that third problem. Which term is negative 182? Well, that negative 182 is somewhere in this dot, dot, dot. Okay, we wanted to know where. Now, we want to figure out where this negative 286 is. Okay, we know it's in the sequence. We know it's in the last spot. So whatever term number it is going to be the total number of terms in the sequence. So we're going to do the same thing we did in the previous problem, but with negative 286. So negative 286 equals negative 13n plus 65. Because again, we don't know, we know negative 286 is a value, but we don't know the n value. We don't know where it is. So we're trying to solve for this n. And again, same two-step process, subtract 65, divide by negative 13, and you will get an n value of 27. So again, 286 minus 65, and then divide that by negative 13. You get an n value of 27, which means there are 27 terms in the sequence. And the 27th term is this last one, which is negative 286. So that's all the types of problems I can give you up to this point in arithmetic sequences.